assistant professor working for Department of Information and Technologies, Vidyavardhana's College of Engineering and Technology, Vasai. In today's video lecture, I am going to discuss about Python arrays using numpy module. Let's move ahead. In last video lecture, we already discussed about some of the point regarding arrays in Python. Total 6 points we already discussed in last lecture is written in blue ink over here, right? The first one is what do you mean by array? Then advantages of using array, how to create an array, right? We are having different way to creating array, right? Then importing the array module, how to import the array module. We are having 3 different way to import an array module. Then we discuss about indexing and slicing on arrays, right? And then processing the arrays. We are having some ready-made methods available in array, so we can use to process our array. So this point we already discussed in last lecture. Okay. To continue that, today we are going to discuss some more point regarding arrays, that is types of arrays, point number 7. So we are having 2 types of arrays, single dimensional array and multi-dimensional array. We'll discuss in few slides. Then next point is working with arrays using numpy. Okay, so we'll discuss numpy module in today's lecture, and then 5 ways for creating numpy arrays. We are having different ways to create numpy arrays. So here we are going to discuss only 5 ways for creating numpy arrays, and then mathematical operations on array. So we'll discuss all 4 points, 7, 8, 9 and 10 in detail in today's video lecture. So first of all, types of arrays, right? So any programming language like C or Java is having 2 types of arrays. First one is single dimensional array and second one is multi-dimensional array. So first understand what do you mean by single dimensional array. Single dimensional array means what? We can represent the elements either in one row or one column, right? One row or one column of the element is nothing but your single dimensional array. For example, marks obtained by a student in 5 subjects can be written in a marks array as marks array, and then I is a type code, as I indicate integer, right? And these are the element 50, 60, 70, 66 and 72. So this is the example of single dimensional array. Why this is single? Because it is consist of only single row, right? Likewise, I can write all this element in vertical fashion as well. 50, then 60, 50 in one line, then 60 in another line, 70, 66 and 72. So this will become my column matrix, means the array consists of only single column. So single row or single column matrix is nothing but your single dimensional array, right? Now next one is multi-dimensional array. So multi-dimensional array is nothing but array with more than one row and more than one column. For example, marks obtained by 3 students, each one in 5 subjects, can be written in marks array as, right? So here I declare one array. The first row in a square bracket 50, 60, 70, 66, 72 is nothing but marks obtained by the first student in 5 subjects. Second row is nothing but marks obtained by the second student in 5 subjects. Third row is nothing but marks obtained by the third student in 5 subjects. So this marks array consists of 3 rows, 1, 2, 3 and 5 columns, and hence it is known as multi-dimensional array. So here we can say a 2-dimensional array is a combination of several single-dimensional array. Similarly, a 3-dimensional array is a combination of several 2-dimensional array. And I can say n-dimensional array is nothing but the collection of several n-1 dimensional array. So hope you understand the concept of single dimensional and multi-dimensional array in C and Java. Okay. So in Python, what happen? In Python, we can create and work with single dimensional array only, right? So in previous video lecture, whatever we talk is related to single dimensional array, right? Python does not support multi-dimensional arrays. So uh, the conclusion is, if we can work on multi-dimensional array or not. Yes, we can work on multi-dimensional array, right, in Python, but we can construct multi-dimensional array using a third party packages like numpy. So numpy is a third party package. The full form of numpy is nothing but numerical Python, right? And this numpy package is very important for programmer. So as I told you, this is a third party package, means whenever you install your Python, numpy is not automatically installed on your system. If you want to work on numpy module, then first you need to install numpy. Okay. So before writing any program using numpy, you must install numpy package on your system. So why to study numpy? Numpy is a package that contains several classes, function, variable, etc. to deal with the scientific calculation in Python. So basically we are going to study numpy module for doing various scientific calculations, right? Second advantage of using numpy, numpy is useful for create and process single as well as multi-dimensional array. So if I want to work on multi-dimensional array, then I need to install numpy, right? Okay. In addition, numpy contains a large library of mathematical functions like linear algebra functions and Fourier transfer. For some mathematical calculation, we can use numpy, for example, linear algebra functions, Fourier transformation, right? For all these mathematical operations, calculation, we require numpy. So to get complete help on numpy, you can refer the following link is written over here, right? https://docs.spy.org numpy references. This is the URL for numpy. If you want to know detail about the numpy, then you can visit this site. Okay. So arrays which are created using numpy are known as n-dimensional array, where n can be any integer. If n equals to 1, it represents one-dimensional array. If n is equals to 2, then it will represent two-dimensional array. Likewise, n is equals to 3, 4, 5, dice. So any dimensional array you can create using numpy. To work with numpy, we should first import numpy module in your Python program. So how to import an package? You already know the syntax: import numpy. Numpy is the name of the package you need to import before using the classes, method, functions available in numpy, right? This will import numpy module into your program, and you can use the functionality of the numpy. So how you can call the numpy, right? The format of calling is numpy.object, right? So we'll write one program here, 24.py, to know how to create arrays in numpy. The 24.py is a simple program to create numpy array, and another version of the program is shown in 25.py. Okay. So I just stop my presentation and move to the programming part, demo part, right? So name of my program is 24.py, student. So I start 24.py program here, right? Where it is? Okay, I open it, file, open, and then I write 24.py. Okay, open this program. So this is a very simple program for creating single dimensional array using numpy. First, I need to import the numpy package, and you need to create an array using numpy. So for creating array, you write just name of the package dot array, right? And in the bracket, you need to give the integer type element if you want to create an integer array, right? And then you need to print the numpy array. So what is array here? Array is nothing but name of the function to create array, right? This function is defined in numpy module. Okay, so let's run this program. So you know how to run this program. Command prompt, and my program is there in D drive Python SDP folder. Name of the program is 24.py, right? I need to compile and run my Python program in this way, right? So this is the output. So in this way, you can create numpy array, right, using numpy module, and this is the output of this program. Okay, so another version of this program is 25.py, right? 25.py program. So here I'm using from numpy import asterisk, creating single dimensional array using numpy, right? So I'm changing the syntax of writing import statement so that I need not write numpy dot. I directly create an array arr object using array function and the elements. The output of this program is similar as the previous program. You can run it using 25.py program. Okay. As you already know, I will give you all the line of codes of all the programs which I explain during this video lecture so that you can run your program on your own system. You can manipulate your program and accordingly you can see the output. Okay. So you require practice. Again, move to the presentation part. So we are having 5 ways for creating numpy arrays. So here we discuss 5 ways for creating numpy arrays. There are several ways to create numpy arrays. Some important functions are first one using array function. Second one is using Linespace function. Third one using log space function. Fourth one using arrange function. And the fifth one using zeros and one function. Okay, so next few slides we are going to discuss each and every function in detail with their syntax and their programming example. Okay, so let's first start with using array function. How to create numpy array using array function. So creating array using array function, we can call array function of numpy module to create an array, right? So this is the syntax. We can using this syntax arr is equals to array and the elements comma int. So if I write int means which type of array I am creating, integer type. So instead of int, if you write float, then it will become the floating point element. And so suppose you skip int over here, you just write array and just the element and then you close the bracket, a small bracket. Then also it is fine. The system will automatically assume the type of array is integer, right? Here also, if one of the element is a floating point, then obviously the system will assume all elements as a floating point element, right? To create an array with character type element, we need not specify the data types at all, right? So in this way, you can create the character array. ARR is equals to array A, B, C, D. So in this way, we can create integer, float, and character types array using array function, right? So Python program to create character type array with group of character is shown in 26.py. Again, we'll discuss a very small program to create a character array. right? The name of the program is 26.py. So here I am importing the numpy module and calling the array function to create my array and type of array is character, right? And display the array. So system will display A, B, C, D. Okay, hope you understand. No need to run this program. Okay. If you run this program, what will be the output? Output is nothing but A, B, C, D is a character array. Now, very important thing, to create a string type array where we can store group of string, we should use additional attribute. D type is equals to str in array function, right? So ARR array is nothing but array with a string. Total 5 strings are there, right? These are the city names: Delhi, Hyderabad, Mumbai, and Ahmedabad. And D type, data type is str, and we can omit the D type str in the above statement, and we can write like this. So both ways are correct to create the string array, right? A Python program to create a string array using numpy shown in 27.py. So my next program 27.py is about creating a string array, right? Just have a look 27.py, right? I import numpy module over here and create an array, right? With 5 city and D type is equals to str print arr, right? It will display the string. So we need to run this program. Okay. So what is the name of the program? 27.py. Okay. And if you omit D type, then what happen? Suppose I omit D type str here. This is optional, right? The system will display the same output. Let's check whether it is displayed or not. Okay. So in both way, you can create a string type of array. Okay. Now it is possible to create an array from another array, right? We can create one array with another array. How it is possible? Just look at the program 28.py. 28.py is to create one array with another array, right? So here I import the numpy module. I create one array. Name of the array is A with the element 1, 2, 3, 4, 5. Integer elements are there, right? So I can write B is equals to array A. Means I am creating one more array B. The element of B are same as array A, right? So create B from using array function, right? And I can write C is equals to A. Create C by assigning A to C. So both way are correct. So B and C array is nothing but the element of array of B and C are nothing but the 1, 2, 3, 4, 5 only. So if you run this program, the output is same for all three printf statement. So name of the program is 28.py student. So here the output is same, right? If you are not following me, then again I repeat. Say A is my original array, 1, 2, 3, 4, 5. I'm printing the original array. Print B. B is nothing but array A, means I'm creating B array using array function. And what is the argument of array function? A, another array, right? So B is nothing but A, and here C is equals to A, means I'm assigning the value of array A to C. So C is again my array. So in this way, I can write a program of array using another array. Okay. So this is all about how you can create numpy array using array function. This is the first method. Okay. Now move toward the second method, how to create array using Linespace function. right? The line space function is used to create an array with evenly space between a starting point and ending point, right? So even distribution of element take place using line space function. So how we can use line space function in this way? Line space with three arguments: start, stop, and end, right? So here start represent the starting element and stop represent the ending element. And what is n here? N is an integer that represent the number of parts the element should be divided, including start and stop, right? And if you don't mention n, then what happen? Then by default the value of n is 50, means by default your array is divided into 50 equal spaces. Okay, so let's take one example to understand this. The program 29.py is there using line space function. Okay, so just open 29.py program here. Okay, so here I am using line space function. My starting index is 0, end one is 10, and my array is divided into n part. N is here 5, right? So my array consists of total 5 elements starting with 0 and with 10, and each distribution is equal distribution. So what will be the output of this program, student? 5 equal spaces. So this is the output. The first one 0, next one 10, right? So by default the line space function will return the floating point value. This array is nothing but your floating point. It will create a floating point array, right? So first element is 0, second one even distribution I want. 2.5, then 5, then 7.5, and then 10. If I equally distribute the element from 0 to 10, so what are the difference in between? 2.5, 2.5, 2.5, and 2.5. This is equal space distribution, as the name suggests, line space. Okay, so hope you understand the second method of creating numpy array, right? Let's move to the presentation part again. Now we discuss the next method, third method of creating numpy array, that is using log space function, right? So in previous slide we discussed about the line space function. Here we are going to discuss about the log space function. Is like a line space. Line space function produce the evenly spaced point. Similarly, log space produces evenly spaced point on a logarithmically spaced scale. Means here the scale distribution is logarithmical, right? The log space function is used in the following format: log space, start, stop, and end. Again, three arguments are there. So what do you mean by this? The log space function start at a value which is 10 to the power of the start, and end at the value which is 10 to the power to stop, right? And if n is not specified, then it will taken as a 50. Okay. For example, I am creating one array A, and A is equals to log space 145. So what do you mean by this? This function represent value starting from 10 power 1. 10 power of start is 1. 10 power 1 to 10 power end 4. These values are divided into 5 equal points, and those points are stored in array A, and division criteria is logarithmic, right? So we'll take one example program, that is 30.py, to understand log space function to create numpy array. .py, here is a program, right? So we are creating an array A using log space function, which is defined in numpy module, right? 1, 4, and 5. 1 is starting index, 4 is a ending start and 5 is a equal distribution, 5 equal distribution, right? So here I'm finding n is equals to len A, means length of A, how many elements are present, right? And I'm using for I in range n, right? I'm going to display the element present in A array, right, using range function. So it will display one digit, not one digit, two digit after decimal point, right? So this log space function will divide the array into logarithmic space, right? So when you calculate it, the output is in a floating point number. So what I want, using this print function, I want to display a two digit after decimal point. So I am using 0.2f. If one digit, then you write 0.1f like this. And every element is separated by the space. Let's run this program. 30.py. Okay, the first element is 10, last element is 10 power 4, 10 power 1 to 10 power 4, and after that a 5 equal distribution based on log scale. So this is the output of this program. Okay, hope you understand the meaning of log space function for creating array, right? So fourth method, creating array using arrange function, right? This is the fourth way of creating numpy arrays. So arrange function in numpy is same as range function in Python, right? So arrange function format is arrange, start, stop, and step size, right? So this create an array with a group of element from start to one element prior to the stop, and the step size is given by the third argument step size. If the step size is omitted, if we need not write, if we don't write anything in step size argument, then by default one is taken. And if the start is omitted, if you are not writing anything in the starting index, then it is taken as a 0, means arrange function will start your array with 0 if we don't mention starting index over here, right? And stop means one less than the stop value, right? For example, I write arrange 10. Arrange 10 means what? 10 is nothing but the compulsory field over here. Compulsory means stop one. The 10 means the system will create an array starting with 0 to 1 minus 10 means 9. Array with element 0 to 9, and obviously the step size is by default 1. So what is the output of this? It will create an array with 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 10 elements are present in the array, right? And suppose I'm writing arrange 1, 10, and 3. Here all three parameters are there in arrange. 1 means my array will start with the 1, stop till 9, and the 3. Right, step size is 3, means my first element is 1, second element is nothing but 1 plus 3 is 4, next element is nothing but 4 plus 7, 4 plus 3 is 7, next element is nothing but 7 plus 3, so 7 plus 3 is 10. So 10 is out of index, the last element must be 9, so only 3 elements are there in array 1, 4, and 7. Okay, hope you understand this. Likewise, you can write arrange function in this way: arrange 10 comma 1 comma minus 1, right? The here step size is -1. -1 means it represents the element in descending order. Start from 10 to starting index is 10 and ending index is what? 1 less than 1 means up to 2, right? In a descending order. So how many elements are there? 10, 9, 8, 7, 6, 5, 4, 3 and 2. The last element is 1 less than this because this is in descending order. So it will, the last element will be the 2, right? So in this way we can create integer array using arrange function. Now one more example. In this way you can create a floating point array as well, right? So I'm using arrange function with 3 arguments 0, comma 10, comma 1.5. So 1.5 is nothing but the point decimal value. 1.5 is a step size, means obviously whatever the output of this program will be my floating point array. Okay. So we write one program 31.py to create an array with even number up to 10. Suppose I want to write one Python program to create an array with even numbers, right? Using arrange function. So how can I write it? To move to the program 31.py. Okay. 31.py is a program. So first you need to import the numpy module and then use the arrange function to create an array, right? So I want to print what? The even number. So I start with the 2, arrange even number up to 10. So last I write 11. So 11 minus 1, 10. And step size is 2. So it will start printing with 2, 2 plus 2, 4, then 6, then 8, then 10. Okay. So if you run this program, is 31.py student. Okay, 31.py, then this is the even number, right? 2, 4, 6, 8 and 10 till 10. Hope you understand the meaning of arrange function to create numpy array. Okay. Now we'll discuss the last way to create, or I can say fifth way to create numpy array. So creating arrays using zeros and one function, as the name suggests, zeros and one. So zero function to create an array with all 0 element, right? And one function is to useful to create an array with all ones. So the zeros and one function to create an array are useful for some mathematical calculation, or I can say some scientific calculation, right? So the how to create zeros array, zeros, n and data type. And represent the number of element, right? And their data types, right? And if we and one n data type means n number of ones over here. The number of ones is mentioned over here, right? So if we do not specify the data type, then the default data type in numpy is float, right? So we'll take one example 32.py to create numpy array using zeros and one. Let's move to the program 32.py. Here is my program 32.py student. First you need to import the numpy module. A is equals to zeros. Zeros function I'm using with 2 arguments, phi and int. Phi means how many elements are present in array A, 5 elements, and zeros. The value of each element should be 0 and type of array is integer. Print A will display the A array, likewise B is equals to 1 and 5 means it will display 5 elements with all 1, and here the data type is float because I am not mentioning anything here. So by default the numpy will take data type as a floating point value, right? So let's run this program 32.py. 32.py student. Okay, so this is the output of this program. The first integer array will print, second one is my floating point array. Okay, of the value 1. Hope you understand how to create array using zeros and one function, right? Next, move to the another slide. Now this one is very important, mathematical operation on arrays, right? So till now we are discussing about single dimensional array only. All of you please note this point. Okay, till now we are going to discuss about single dimensional array only. In next video lecture we are going to start multi-dimensional array. So as you already know, numpy, using numpy you can create single dimensional as well as n dimensional, or I can say multi-dimensional array. So it is possible to perform various mathematical operation like addition, subtraction, division, etc. on the element of an array, right? So to add two array A and B, we can simply write A plus B. Similarly, to divide one array A with another array B, we can write A divided by B. If you multiply two array, then you can write A into B. If you want to subtract two array, then you can write A minus B. So all the mathematical operation is can be performed in numpy arrays, right? So this kind of operations, plus, minus, multiplication, division, are known as vectorized operation. Since the entire array or vector is processed just like a variable. Why it is vectorized variable? If you write A plus B, so it is not just addition of two variable. You are adding two arrays, right? And suppose you're writing A divided by B, means you are dividing two array element, right? So these operations are very important in numpy, because same program if you want to write in C and Java to add two matrix or add two arrays, single dimensional array if you want to add, then how can you write a program in C? You need to use for loop and you need to add corresponding element present in the array. But here in numpy you can just use arithmetic operation plus to add two number, subtract to subtract two arrays. Likewise, you can perform any mathematical operation on numpy array, right? This point is very important. So here I will explain you one more example, 33.py, to show how to apply mathematical operation on array, right? So I open one program, 33.py. So this program is about mathematical operation on arrays, right? First we need to import the numpy. Don't forget to import numpy, otherwise system will give you error, right? So first create one array ARR with 5 element 10, 20, 30.5 minus 40. So which type of array it is? The data type of array is float, right? Because one floating point element is present. The system will consider this array as a floating point array. The first print statement will display the original array, right? Let's run this program and check every line of code one by one. So name of my program is 33.py. Okay, so this is the output of various print statement. Okay, let me open the program here. The first print statement will display the original array. So I already told you this system will consider it as a floating point because one of the element is float, right? Now next one, I'm applying some mathematical operation on the element, right? So after adding 5, I can write ARR plus 5 means plus 5. 5 is added with each and every element in array. So after adding 5, what is the output? My 10 become 15, 20 become 25 like this. Each and every element is added with 5. And this is the output, right? Wise. Next line number 9, print after subtracting 5. Subtraction operation, you can apply the elements, you can apply on each element of the array, like ARR minus 5. So it will give you this, right? Likewise, multiply with 5. Each element is multiply with 5, right? In line number 10, line number 11, after dividing with 5, each element is divided with 5, right? And line number 12, we apply the modulus operator over here. Each element of array is modulo division by 5, and this is the output after modulus with 5, right? So in this way we can apply some operation on array, okay? And again, I can use the arrays in expression also. We can use the arrays in expression also. So suppose expression value I want to calculate ARR plus 5 into 2 minus 10. So you already know double into sign means is a power of. So whatever value is there, each element plus 5 power of 2 minus 10. This entire expression value corresponding to each element is displayed over here, right? So this is the beauty of numpy module. Every expression value you can apply on each and every element in single statement, right? So here I'm next line number 15. I create one more array over here with some element 2, 10, 2, 5 and 5. And suppose you want print statement, if you want to add this to array, the previous array ARR plus this B array, then system will give you this, right? The output of all this array is floating point data type. I can apply plus, minus, multiplication and division operation on array, means addition of two array, subtraction of two array, division and modulo division of two array. Okay, so task is very simple using numpy module. Same program if you want to write in C and Java, then it require so many line of code and you need to apply looping concept for this, right? To do all this job, but it's very simple to do all this in Python. So hope you understand mathematical operation on arrays, right? So next slide is about some useful mathematical function in NumPy, right? So this slide is very important. Here you can use some ready-made function available in NumPy, right? In your program. So some of the functions are displayed over here. Suppose you want to know the tangent value, then you can use tan function and in the bracket name of the array, right? So it will calculate the tangent value of each element in the array. So these are some trigonometry function you can apply. Likewise, tan function you can apply the sine function, cosine function, tangent function like this, right? Then ARC sin and then in bracket ARF function calculate the sine inverse value of each element of the array, right? Likewise, AR cos function calculate the cosine inverse value of each element in the array. These are all trigonometry functions, right? Likewise, ARC10 will calculate the tangent inverse value of each element in the array, right? And suppose you want to find out the natural logarithmic value of each element in the array, then you use the log function, and in the bracket, obviously, the argument is the name of the array, right? Next one is the absolute function, It will calculate the absolute value of each element in the array, ARR, right? Next, very important function is it is sqrt function. It calculates the square root value of each element in the array. Next, power of function, power ARR n. It returns the power value of each element in the array, right? When raised to power of n. This function will return some value. Which value? The element of array power of n, right? Next one, exp ARR. This calculate exponential value of each element present in array, right? Next, very important function, sum and then ARR. It will returns sum of element present in array. If you want to find out the summation of marks of each student, then you can directly use the sum function in name of the array. The system will give you the output in a second. And the line of code is again very simple. You just use the sum function, ready-made function available in numpy, right? Likewise, product function is there. Product function is the name suggests prod, product. It returns product of all the elements in array. It will multiply all the elements present in array and will display the output. So all of you please remember, all this function we are using in single dimensional array only. Okay. For multi-dimensional array, we will take one more video lecture to explain a multi-dimensional array using numpy. Okay. Some more functions are there which you can apply on numpy. First, that is mean. Mean returns the mean value, or I can say average value of all the element present in the array. Then median returns the median value of all the element present in the array. Then var function. Var function returns the variance of all the elements in array, right? So I already told you before that the numpy module is useful for some scientific calculation. So whenever you are talking about the scientific calculation, you must know the mathematical functions, right? So all this mathematical function you can perform using numpy module very easily, right? Likewise, you are having a standard deviation function. Then you are having if you want to find out index of the smallest element in the array, start from the 0, then you can use argmin. Argmin function will give you the index of the smallest element in the array, right? The reverse is argmax. It will give the index of the biggest element in the array, counting start from the 0, right? And then unique function, it will gives an array that contains a unique element of the array, right? If data duplication is there, then unique function will give you the list of all unique element present in the array, right? Next very important function is a sort an array. It gives an array with sorted element of the array. By default it will give you ascending order of sorting, right? Now next one is concatenate. If you want to join to array, if you want to combine to array, then you can use concatenate function. Obviously here we require two arrays, a comma b, returns an array after joining a and b, right? And the arrays a and b should be entered as an element of the list. So what is the condition for concatenate function? A and b, the argument a and b is a element of a list. Okay, so these are some mathematical useful function already available in numpy. You just import the numpy module and you can use all this function for your program. Okay, so program 34.py shows some of the mathematical functions shown in above table. So I write simple program 34.py here to understand some of the mathematical function defined in this slide and above slide. Okay. 34.py. This is the last program for this demo lecture. So here mathematical operation on the arrays, right? First we need to import the numpy module. and you need to create numpy array using array function, arr array, and with all 5 elements. So type of this array is float, right? So we need to apply some mathematical function over here. Suppose I want to find out the sign values of all the element present in array. So I can use sign function, sign array, sub cosine value, then cos function, tangent value, then tan function. Suppose I want to find out the biggest element of this array, then I can use max function. To find out the smallest element, I can use mean function. And then to find out the sum of the element, I can use sum function. It will find out the summation of each and every element present in the array. And if I want to find out the average of all the elements present in the array, then I can use mean function, right? So let's run this program 34.py. This is my 34.py program, right? Just shift this notepad window over here so that you can see the output and program together. Sorry. Okay. The first print statement will display the original array, that is 10, 20, 30.5 minus 40. Second statement will display the sign value of each and every element. 10 ka sign value is this, 20 this, like this, right? Then next print will statement will display the cosine value of all the elements. Next will display the tangent value of all this, right? And next print value will find out the maximum element, the biggest element. Which one is the biggest element over here? Is 30.5, obviously. It was displayed over here. Then smallest element, negative value is the smallest element over here. Then the next one, sum function will find out the summation of all 4 elements. The result is 20.5. And the next one, mean function will display the average of all the element. All 4 element average is 5.125. So it's a very simple program. It's very simple, but you need to remember the name of the functions available in numpy module. If you remember the function, then it's very easy to do all this calculation, all this scientific calculation, right? If not, then you can write a program using looping, iteration, right? Same logic you need to apply as a C program. C program, whatever logic you apply in the C program, same logic you need to apply here. If you don't remember the name of the ready-made function available in numpy and their uses, right? So this is, I think, last slide of this video presentation. Sorry. So in this video lecture, we discuss about types of array. 2 types of arrays are there. Then working with numpy array, right? And then how to create numpy array using different ways. We discuss total 5 ways for creating numpy array using array function, using Linespace function, log space function, arrays function, and zeros and one function, right? After that, we'll discuss about some mathematical operation, or I can say vectorize operation on array in program 33.py, right? After this, we discuss some mathematical function like sine, cos, square t, exponential, absolute function in a table, and we write one program for that, that is 34.py. These are the list of some mathematical function available in numpy. Okay, now this is a time for programming assignment. So hope you understand this video lecture well. Okay, so you need to execute 4 program here. First program is write a Python program to find out sum of odd numbers present in array, integer array using numpy. Right? Using numpy array means first you need to create array using numpy, and after that you need to find out the odd numbers in your program and find out the summation of odd number present in your array. Right? Second program is write a program to take input as a decimal number from the user, store the element in the array, and sort an element present in array using numpy. Right? So first you need to take input from user as a decimal point number, store, create an array, and then you need to sort that array. Next program, you need to write a Python program to find out area of circle, triangle, and rectangle. Right? Obviously, for this program, you need to use some ready-made function available in NumPy. Right? Next program, fourth one, write a program to find out sum of square roots of each element present in NumPy. When suppose 5 elements are there in your NumPy array, then you need to find out square root of each 5 elements, and then after that you need to find out summation of square root of each element. Okay, so this is your programming assignment. You need to submit me. Okay, so it's time to say goodbye. So all these slides, all this video presentation is prepared from a book by Dr. R. Nageshwar Rao, Core Python Programming, second edition, Ville India Kindle edition. Thank you very much for listening my video lecture. Okay, if you have any queries, then you can mail me on mariam.javadwala@vcet.edu.in. Bye.